Hi, so we're ready to start the fourth section in Chapter 1, which is titled Other Effective Sampling Methods. So in the last section, we looked at what's known as simple random sampling. So there are some other methods that we can use as well that we want to take a look at for in this section. So the first thing here before we start Objective 1 is just kind of making sure you understand what the goal of the sampling is, right? So the goal of sampling is to obtain as much information as possible about the population at the least cost, right? That's the whole goal, right? We want to gather as much information as we can about the population, but we want to have the least cost, right? That's the main goal of sampling. And cost here, you want to consider, these are monetary outlays, so actual, spending of money essentially, right? But also, you want to think about other resources, not just financial resources, but also just the time it takes and other resources that we might need to do the sampling, right? So cost here includes more things than just like money, right? Just to make that clear. And then so it may be better for us to use a different sampling technique than just a simple random sampling, right? So we're going to look at some of those. So the first we're going to look at is what's called a stratified sample, right? So that's Objective 1. So a stratified sample is obtained by separating the population into non-overlapping groups called strata, and then obtaining a simple random sample from each stratum. The individuals within each stratum should be homogeneous or similar in some way, right? So essentially, essentially we're taking the population and putting them into some group based on some characteristics, but we don't want one individual to be in multiple groups, right? As stated. So if you take a look and pause this video and read over example 1, you'll see that is a stratified sample. So our strata here would be the managers and hourly employees, right? So pause this video, read over this example, and you'll see that these two groups is a strata, right? So just a note here, a general note about stratified sampling is that we can often get more information about the population for less cost than simple random sampling. Alright, so now ready to look at example 1. So what we have is we have owners of a private food store. We're trying to figure out about employee morale. So the owner decides to survey the managers and hourly employees to see if we can learn something about work environment, job satisfaction. So we want to obtain a stratified sample of two managers and 4 hourly employees, right? So essentially to do this, right, we want to split our population into strata, which we already did, right? We have managers here and hourly employees here, so these are my two groups, my strata, right? That's based on our categories. And then next what I want to do is I'm going to number in the manager list 1 through 8, right? So we got 1, 2, 3, 4, 5, 6, 7, 8, right? So essentially I'm assigning like an ID number to everyone that's a manager. And then next, what I want to do is assign ID numbers for the hourly employees, right? So 1, 2, 3, 4, and so forth. Right, so you should get 21 hourly employees. Right. So then, once you've done this, right, what we want to do is select a simple random sample from each of the strata, right? So if we look at the managers, right, you can see that we want to select 2 managers. Oops, I had to use the highlighter there. We want 2 managers, right? So I want to select a simple random sample between the numbers 1 through 8 because I have 8 managers. I want to select with a size of 2, and I want those to be without replacement, right? Because that makes sense. So what we can do is we can use R to figure this out. So remember the R command, the code you're going to use. You're going to type in sample, and then the inputs in parentheses, you'll type the minimum number, which is 1, and then you'll do a colon, and then you'll type the maximum number, which is 8, and then we'll do comma, we'll type size equals, and then I'll put the size I want here, which is 2, right? I want 2 numbers to be selected, and then we have to indicate that we want the replacement turned off. Right, so we do replace equals false in all caps. Right, that's what we're going to type into R, right, to pick this simple random sample. So let me open up R. Let me go ahead and make the text a little bigger. Oops. Hang on. All right. All right, so I'm just going to type that into R. So we'll type in sample 1 to 8, comma, size equals 2, comma, replace equals false, and we get the random numbers 1, 3. Right. So this gave me back, the output was 1, comma 3. So the people that would give me back would be manager number 1, which is what, Carlisle, and manager number 3, which is Katz. Right? So those are my 2 managers that I want. So then next, we want to look at the hourly employees. Right? So with the hourly employees, we want 4 of them. Right? So we're going to do something similar. So I'm going to do like a simple random sample. Right? I want to get a simple random sample between the numbers 1 to 21. This time I want a size of 4. I want to pick 4 hourly employees, and I still want the replacement turned off. Right, so I'll make the replace false. So do this without replacement. Right, so then I can come over to R, and I can type that in. So we got sample parenthesis 1 to 21, comma, size equals 4, comma, replace equals false. So we get these numbers. So we get so with that, I got 21, 12, 7, 10, right? So those would correspond to the people, right? So the 21st person is, I'm not sure how to pronounce that, Zavidny, maybe? I don't know. Then number 12 is Houston. Number 7 is Everhart. And number 10 is Grove. Right, so those are my hourly employees, right? So then my my stratified sample right, so really like my final answer, right, what I'm looking for, my stratified sample would contain all these people, right? So we got the 2 managers and the hourly employees. Right? So that's what I was after. Right? So that's the idea of a stratified sample, right? So we're separating the population into strata, right? These non-overlapping groups, and then we're obtaining a simple random sample from each of the groups. Right? So just some things to note here is you could use R, StatCrunch, or TI-84 with this, so you would just follow those steps I presented with section 1.3. And also one thing to note is that I used a dynamic seed, right? So I did not set a seed in R when I did this, right? So if you remember, I pull my R codes back over here, right? I did not set a sample. So, you know, that's randomly picking some sample. You know, I'm not quite sure how R picks a sample when you do a dynamic sample, but it could be, you know, like this happens to be the value in the seconds of the time when you type that command in, right? Something of that sort. So you're not going to get the same results as me if you try this. If we had used the same seed, that would be true, right? But something else to keep in mind here is that when you're repeating the simple random sample, you want to use different seeds, right? So when I typed in this first line and then the second line, so in other words doing the managers and the hourly employees, you would not want to use the same seed number for both, right? Because you don't want that to influence your randomness. You'd want to use a different seed. So since I use a dynamic seed, I mean, it's very probable that I had different seeds in each case, right? So I was relying on that, and that's why I did it that way. You know, something else to think about is you could use like a dynamic seed to pick your 2 seeds that you would use, right? So for example, you could come into R and say like sample 1, 2, I don't know, whatever you want to do, maybe like 1,000. We want size equals 2, replace equals false, right? So what this is going to do is use a dynamic seed to pick 2 numbers between 1 and 1,000. So if I hit enter, there's my 2 numbers. So then I could use 820 as my first seed for the managers, and then 927 as my seed for the hourly employees, right? So that's one way, you know, you could get those 2 different seeds, right? All right, so ready for look at the next sampling method. So the next one is called a systematic sample. So that's objective 2. So a systematic sample is obtained by selecting every kth individual from the population. The first individual selected corresponds to a random number between 1 and k, right? So we're randomly going to pick a starting person, right? So, if I randomly pick someone that's walking out of Kroger's, let's say, and then from then on, I survey every 50th person that walks out the door, right? So, something like that, right? So that's just, an easy kind of way that you might be thinking about what a systematic sample looks like, right? So all of these sampling methods do have some pros and cons. So one plus to a systematic sample is that it doesn't require a frame, right? So let me just make a note of that. So this doesn't require a frame. And remember, a frame is a list of all individuals in the population. Right? So in other words, if we don't know how big the population size is, maybe, or we can't, it's really hard to list them all, then this would be a good way to do that, right? So for example, if I was surveying Kroger customers, it's not really possible for me to determine all the people that would be shopping at Kroger that day, right? So this type of method would work for that because we don't have to know all the individuals. But one thing that we need to be able to do, and you can see in the steps for systematic sampling, we do need to be able to approximate the population size, which is capital N. And there's some methods that we'll look at later in the course to how to approximate that. And then from there, we want to determine the sample size desired. So we use a little n for the sample size. And then step 3, we're going to take big N divided by little n, and then we're going to round down. And that value we're going to call k. Step 4, we're next going to randomly pick a number between 1 and k. And that's going to be our starting point. And we're going to call this number p. And then the sampling will consist of the following individuals, right? And you can see it's written out here in, as like a arithmetic sequence, right? So maybe you studied like arithmetic sequences maybe in high school. Or if you took Math 910, you definitely looked at those. So, an arithmetic sequence is like a linear function, right? So you're adding a set amount each time, right? So essentially, you're going to start at that value p, that random number you picked, and then you're just going to keep adding a number each time, right? So let's say my random starting point number happened to be like 4, and then my k value was like 6, right? So then you would add 6 each time to get your value, right? So we'd have 10, 16, and then 22, and so forth. Right, so just to make this a little easier, maybe this is my p, my starting value. It's randomly chosen. This is k, which is what we're adding each time, right? So this is just, just like a quick example. Right. All right, so I just wanted to review with you real quick, maybe something you've seen before, maybe something that you haven't covered, but just to make you aware of what's called a floor and ceiling function. So like here I have written, this is read as the floor of 2.4, right? So you'll notice it's kind of like a bracket, but doesn't have the top part, the bottom part, but the top part's there, indicating like upward, right? So let me maybe write that a little better. So like if we have like 2.4 and then have something like that, right? So so this is the ceiling of 2.4. Right? So the ceiling function, what you do is you always go up to the next integer. So it's kind of like rounding up, if you will, but you don't round like you normally do in a typical sense, right? And if you don't know what I mean by integers, right? So integers are these numbers, right? I'll keep going forever. So, they're positive, negatives, but there's no fraction or decimal part, right? So these are integers. Right? So, in other words, we're going to like the next whole number, right? So 2.4, the ceiling of that is 3. So then if I had the floor of 2.4, right? So something that looks like that, right? So in other words, instead of the horizontal lines being at the top, now they're at the bottom, indicating we're talking about the bottom, which is the floor. So in this case, you just always round down. So it would be 2, right? So again, it's not the rounding like we typically would have. So this is the floor of 2.4. Whoops. Grab the eraser. Right. So so with the ceiling of 2.4, you essentially round up, if you will. And with the floor, you're going to round down. Right. And if you're interested, if you take the ceiling of like, let's say 25, that's also equal to the floor of 25, which they're both just 25, right? So if you land on an integer, or if you have an integer, inside, you get just that integer back, right? So the reason why I bring that up is I just want to point out, because you maybe have never rounded like that before, and if you really pay attention to number 3, it says round down to this nearest integer, right? So you're always going downward. So in other words, what we could say is that you're going to take the floor, right, of capital N divided by N, right? So in other words, another way to write this, so for number 3, we could say K equals the floor of big N divided by little n, right? So that's what I was after, so I can write it in that fashion. All right. So now I want to look at an example of this. So we're looking at predicting the outcomes of a county election, and our local newspaper obtains a list of all 945,035 registered voters in the county, and we want to conduct a systematic sample. So the first thing we want to do is, the step, right? If possible, we want to approximate the population size, which is capital N, but we already know that, right? So this value here tells me that capital N is equal to this value, right? Second thing is we want the sample size. That's provided here, right? So little n equals 130. So that's provided for us. Then, the third step is we want to calculate K. So that's actually what this part A is asking us to do, right? So remember, K is equal to the floor of big N divided by little n, which in this case would be equal to 945,035 divided by little n, which is 130. we want to take the ceiling of that. So this would be equal to, let me just go ahead and move this, maybe write this with a different color. So this tells me that little n is 130. Right. And this was 30. Oops, let me just erase that. There, it's a little better. So what I'm going to do is I'm going to just do some arithmetic inside of R. Alright, so just pull all our R over. And what I want to do is take 945,035 divided by 130, and we get 7,269.5. Right, so I can fill that in. Right, so if you notice, we're actually able to use R to do some basic, just some basic calculations as well, like add, subtract, multiply, divide. Works pretty well. So this would be equal to the floor of 7,269.5, which this would be 7,269. Right, so you're just always going downward. Right, so then part B, which would be really steps 4 and 5 in the list above, we want to determine the individuals who would be administered in the survey. Notice it says that more than one answer is possible, right? So the first thing that we need is we need to find a random number between 1 and k, right? So we need a random number between 1 and k equals 7,269. Right? So in order to get that random number, you should use like a random number table, or a TI-84 or StatCrunch or R to calculate that. So I'm going to use R. Right, so I'm going to type in sample, and then we want a number between 1 and 7,269. My size is 1. I just want one number, and we don't want replacement, but it doesn't matter here because we're only picking one number. It's not a big deal. Hit enter. And there's my random number, right? So my random number, my p value, my starting number, is that 1,506, right? So you don't want to just pick a number like in your head. You want to actually do some kind of something like this to get what we call like a pseudo-random number, right? I mentioned that before in a previous video, but I mean, really, randomness is actually quite hard to replicate, right? But this is the best we can do. But you trying to pick a number in your head definitely isn't very random, right? So make sure you make note of that. And as we keep going through the course, I think you'll get a better sense of randomness. What is randomness? Right, so what we found is that P equals, right, and just to write this out, I typed in the code sample 1:7,269, comma, size equals 1, comma, replace equals false, and I got 1,506. Right, so that's going to be my starting value. So I would have 1,506, and I know typically, especially the bigger numbers we get, we like to put, commas to separate periods in the number. But I'm not going to do that here because it'll be confusing with the commas that actually separate the numbers, right? So what we would have is 1,506, and then I need to add k to this, right? So this would be 1,506, plus 7,269. And then we'd have comma, and then I would have 1,506 plus 2 times 7,269. And then we would have, 1,506 plus 3 times 7,269. And then we keep going. Then lastly, we would end at the number 1,506 plus, and this number would be n minus 1. So my n value was, 130. So this would be 130 minus 1 times 7,269. That would be my last number, my 130th number. Right? And if you're having trouble with this, right, this is just pulling it apart from step 5, the equation. Right, so if I scroll up here, what I'm using is this equation here. Whoops. Trying to get the eraser. There we go. I wanted the highlighter. Right, this equation I just highlighted in yellow. Right, so you can see if we focus in, this part I'm underlining in red, that's that last term. Right, so I wrote it out in that way. I filled in the value for P, filled in the value for N and K, and that's what we get. It looks like that. Right, that's that last term. Right, so this is the arithmetic sequence. Right, so we can simplify this, right? So what this would give me is the sequence of numbers. So if we take, 1506 is going to be my first number. And if I take 1506 1506 plus 7,269. So I'm just typing that into R on another monitor, but you can type it in your calculator. That second number you should get 8,775. And then if you take that number, 8,775, and then add another 7,269 to it, you should get 16,044. Right, and again, typically, especially when we have more than 4 digits, I would put a comma here in between the 6, but I'm not going to do that, so it doesn't get confusing. Right, and then these would keep going. Then lastly, so I'm going to type in the equation. So we'd have 1506 plus 130 minus 1 times 7,269, and get that last value. And let me pull over my R here so you can see what I typed in. Right, so you can see these last 3 lines are what I was typing in if you wanted to follow along. So I'm just using R like a calculator. So that very last number, we get 939,207. Alright, so 939,207. Right, so that's the sequence of numbers that I'm after. I also want to show you real quick how you can easily get this list on Excel. So, if I was doing this, especially with 130 things in my sample size, if I wanted to get all of these, I would definitely use Excel. Whoops. Alright, so let me just open up a blank workbook. Zoom in a little bit. So in the first cell, I'm just going to type in 1, and then I'm going to do equals, type the cell above it and hit 1. And then a cool thing in Excel is if I fill this down, what it'll do is it'll keep taking the number and adding 1 to it. So we need to go all the way down until we get to 130. There. So those are the individuals that we chosen. The very first number, my p-value, I'm starting out with. Let's see, that was, let me just check here, I forget, 1,506, so we'd put that here. And then the number that I'm adding each time, that was 7,269. Right, so what I typed here is equals, and then this column, or this cell that I was at, and then plus 7,269. If I hit enter, what it did is it took that cell in blue that I told it to and added that number to it. And then, like I said, a cool thing about Excel formula is that if I drag this down, so if I put my cursor in that corner and drag this down, it'll keep adding that that number through. Right, it's pretty smart. But I'm actually gonna show you something else that's kind of cool. Is if I double click on this, it'll pull it all the way down to where I last entered data in that row. So you can see that was the same number that we had gotten from our calculation, right? That 130th digit. And you can double check the first couple. So I think we wrote down the first 3, and those are accurate as well, right? But that gives us, that's a nice, easy, quick way to give us the whole list, in practicality. All right, so now we're ready to look at Objective 3. So Objective 3 is looking at obtaining a cluster sample. So a cluster sample is obtained by selecting all individuals within a randomly selected collection or group of individuals, right? So essentially, we'll have everyone split into groups, and then we randomly choose a group, and you survey everyone in that group, right? So you can almost think about it as, I don't know, like if you were trying to survey, I don't know, maybe you're an electrical company and you're trying to survey your customers in a particular city. What you could do is you could have each grouping be like a city block, right? So everyone within that city block would be in a group, and then you then you would number each of the city blocks and then randomly select numbers, and then if number 3 is picked, then you would find block 3 from your map, and then you would survey everyone in that map. Right. So one benefit to that, especially if you were measuring or surveying people within a city, that prevents you from driving all over the city. Makes it a little more organized geographically, right? So that's one benefit to that. So I have example 3 here. It says to obtain students' opinion about proposed changes to course registration procedures, the administration of a small college asked for faculty volunteers who are willing to administer a survey in one of their classes. 23 faculty members volunteered. Each faculty member gave the survey to all the students in one course of their choosing. Would this sampling method be considered a cluster sample? Why or why not? Right? So if you think about this a little bit, we kind of have these groupings, these clusters made, and that's the classes, right? But this is, they're not being randomly selected, right? We're not using some kind of like random number table or random number generator to like try to randomly select who's going to be in this. We're basically just asking like, hey, who wants to survey your class? And then you can just pick whatever one you want. That's not very random at all, right? So we would say no. The clusters were not randomly selected. So this would be considered convenience sampling, right? And I'll explain and come back to this why it's convenience sampling. I'm going to explain what that is on the next page. But essentially, you can kind of pick convenient sampling as you're doing something that's convenient. It's not really random, right? It's maybe the easiest way to think about it. So it's convenient for me just to ask, who wants to do it. It's like easy, and it's definitely not random, right? So maybe another note you could note here is that clusters here are the classes, right? So the individual class, right? So like if you have, math 1240 section 02, that meets on Tuesdays and Thursdays from 11 to 12:20, right? This is one section, right? So what we're doing is we're treating each of these as a grouping, right? A grouping of students. So, we could turn this into cluster sample if we wanted, but what we would need to do is we would need to have like a list of all the classes, number them 1 through whatever, how many ever classes we have, and then randomly choose numbers, which in turn randomly chooses the classes, right, the corresponding classes to these numbers, and then we would survey everyone in that class, and that would be, more like a cluster sample, but example 3 definitely is not, because of there's no random choosing of these clusters, right? And a benefit here in like this example is that this there's less classes being surveyed. So if someone needs to go into a room to administer this survey, they don't have to go to as many classes. Where if we randomly picked students to like a simple random sampling, if you will, then they would potentially be in a lot of different classes that they'd have to go in, and not everyone in the class would be surveyed. And so doing something like this, it makes a lot more sense to survey everyone in the class. So cluster sample makes sense here. Right, so then this table or this chart is a summary of the sampling methods that we've talked about. So the first one is simple random sampling. So that's what we talked about in the last section. So remember, that's where we're randomly choosing a sample, right? So the sample is randomly chosen. Right, so we're assigning a number to everybody and then just randomly picking the numbers that we want, and that creates the sample, right? So like here, we were trying to get a sample size of 3, right? We just randomly picked numbers in here, right? And then the next type here on the table is stratified sampling. So remember, the idea here is we have a population, And then we put them into non-overlapping groups. And remember, these non-overlapping groups also have some characteristics in common, right? And those groups are called strata. And then we're randomly picking people out of each strata to be in the sample, right? So you want to remember that. And then looking at the systematic sampling. So remember here, this initial value is randomly chosen. Right, that was our p-value, right? And then we calculate k, and then every kth person is selected, right? So in this case, every third person is selected, right? So we're adding 3 each time. So 2 plus 3 is 5, 5 plus 3 is 8, 8 plus 3 is 11, so forth. Right, so we're picking every third person. So it's very systematic, right? We have a starting point, and then we sample every kth person. And then lastly, the cluster sampling, right, is where we have, our population. We cut it into groups, right, which we are calling clusters. And then we randomly pick what clusters we survey, and everyone in that grouping, that cluster, gets surveyed. Right, so those diagrams just model that. Right. So at the top here, I just have a note. So stratified and cluster samples are different. In a stratified sample, we divide the population in 2 or more homogeneous groups. And remember, homogeneous groups are groups with similar individuals. Then we obtain a simple random sample from each group. And then in a cluster sample, we divide the population into groups and then obtain a simple random sample of some of the groups and survey all individuals in the selected groups. Right? So those are different. You want to note the difference between the two. So I think some people get those mixed up a little bit because they both involve groups, but and just remember, like the cluster sampling, just think of like city blocks, if you will, right? That's how I kind of keep that apart. So then, as promised, the next thing I want to talk about is convenience sampling. So I have here the definition. So a convenience sample is a sample in which the individuals are easily obtained and not based on randomness, right? So it's convenient for us, right? So have here some fill in the blanks, a statement here. So the most popular of the many types of convenience samples are those in which the individuals in the sample are self-selected, in other words, the individuals themselves decide to participate in a survey. They are also called voluntary response samples. Right? And with this, something you want to keep in mind or be cautious of is that, most of the time when you're doing like a voluntary response survey, a sample, not everyone chooses to participate, and what you end up getting are people that feel really strongly or against, so either for or against some particular issue. Like they have some strong opinions either way, but people that are in the middle, more neutral or kind of mixed emotions, normally those people don't go through the effort to respond to the survey, right? So if you're doing a voluntary response survey about maybe what presidential candidate that you prefer, right? So people that feel really strongly about one candidate or the other, they're going to respond to your survey. But the people who are more in the middle, like, I don't know what to do, or I don't like either of them or whatnot, they're probably not going to respond to the survey, right? So really we want that randomness in there to make sure we get a good mix to represent the population, right? And we're going to talk more about that those ideas in the next section, I believe, when we talk about bias. All right. So another example of convenience sampling I have here is if let's say I was asked to determine the proportion of Marion Technical College students that own a Chromebook, and what I do is just send a survey out to only the students in my classes that I'm teaching, right? So that's not necessarily a good mix of, all the students at Marion Tech. It is not built on randomness. I just did something convenient. I'm just surveying my students. I can persuade them to fill it out, and I don't have to, go to other classes and get them to fill out the survey, or rely on other faculty to send out the survey or whatnot. So that's an example of convenience. Another note to think about is if you have like a large scale study, it's pretty normal to use a combination of sampling techniques. So if you look on page 35 in the textbook, they talk about a couple of examples of this if you're interested, and they also give you a resource of what some ideas of what this looks like, and how maybe some people do this. So if you're interested, I would check that out. And later in the course, so towards the end, when we're in this chapter 9, 9.1, 9.2, we're going to talk more about like how to determine the sample size that we need, right? So right now we're kind of given that, but we later towards the end we'll be able to talk about that a little better. Right, so what I have left is determining the sampling method used in each of these scenarios. So give us some practice. So if you would pause the video, read over these 3 sampling scenarios, and then we can talk about them. All right, so now that you've had a chance to read over those, I want to talk about each one and so forth. So if you look at number A, the kind of the key thing here is that you're starting with a random chosen number, right? So random chosen number, and you're surveying every 40th student. So hopefully you know that that's systematic sampling. Right? So then if you look at the next one, part B, it's so that one deals with nursing homes. So if you read that carefully, after reading that, what you should notice is that essentially every nursing home is a cluster, right? So you're randomly picking a nursing home and then surveying everyone in that nursing home. So you should recognize that as cluster sampling. And then lastly, we have in a study of lung function, right, we have these 3 groups, and each 3 groups is going to split the population into 3 different strata, right? So there are 3 different groups that don't overlap, and everyone in that particular group has something in common. They're homogeneous groups. And then we're taking a simple random sample from each of the groups, so hopefully you recognize that as stratified sampling, right? So the strata is the 1, 2, 3, right? All right, so that's all I have for this section. So make sure you let me know if you have any questions. Thanks.